If we want to be able to dynamically allocate structure arrays or structure variables, then we're going to have to be able to create pointers to structures. A structure variable has a memory address, just like any other variable. And of course, that memory address is a hexadecimal value. Pointers to structures are variables that can hold the address of a structure. So if I were to create a pointer to a student, called stu_pointer, this pointer could hold the memory address of a structure variable. And then assuming that I have created a student variable called stu_1, this is stu_1, which has the student name and GPA and all that kind of stuff. And then if I put the memory address of stu_1 inside of stu_pointer, that's going to create that connection. And I can now access the stu_1 structure through this pointer. A structure pointer can also be a function parameter. In order to dereference the pointer variable so that you can actually access the members inside of that structure, you have to use the parentheses. And this is because the precedence of the dot operator is higher than the precedence of the indirection operator. But we don't want to first access a memory addresses member student ID because it doesn't have a member. You want to first dereference stu_pointer so that you're then accessing the actual structure that you need to access and then accessing the member for that structure. Now this is kind of a headache to do this syntax every time. And so in C++, we have a way that we can do this to actually dereference a structure pointer by using an operator called the pointer operator. The cool thing is that it actually does look like an arrow, which will help you to remember that you use it whenever you're using a pointer. So stu_pointer is a pointer to a structure, and this is our pointer operator, so we are dereferencing the pointer to access the student ID member. I'm going to show you this example in a minute, structure or struct pointer 1. But I first want to talk about dynamic memory allocation, which is one of the primary reasons you would ever want to create a pointer to a structure variable. So in this example, I create my pointer, I call it stu_pointer, and then I dynamically allocate a single student variable. And then, of course, the new operator returns the memory address of this student. So stu_pointer is the name of our student, and it's the only way to access this new student. And whenever we access this student's members, we have to go through stu_pointer using that pointer operator. But you can also dynamically allocate a structure array, which of course is more common. So we first create our structure pointer variable, stu_pointer arr, and this is going to be our array name. Then on the next line, I created an array of 100 students. And I return the memory address because of the new operator. And so stu_pointer array points to this newly allocated array. Once I'm done filling up the array elements, I then need to make sure that I release the memory. And I would do that by putting delete and then the empty square brackets since it's an array, and then the name of the pointer. I have a couple examples that I'm going to show of dynamic memory allocation. Okay, here's the first example, struct pointer 1. I have my student structure declaration. The student structure has a name, ID num, credit hours, and a GPA. Then I have a function called getData, and I have a pointer to a student that I'm passing to this function. So in other words, I'm passing a memory address to the getData function. In the main function, I create a student named Freshman. So Freshman has a name, an ID num, a credit hours, and a GPA. Okay, that's created in the main function. Then I say enter the following data, and I send the memory address of Freshman down to the getData function. In the getData function, I have a pointer to a student called S, and S now has the memory address of Freshman. So now I can access the Freshman name, ID num, credit hours, and GPA through S and using the pointer operator. So to get the name, I use S pointer operator name. To get the ID num, I do S pointer operator ID num. So let's say the name is Bob Ross. And then the user enters the ID num 125. And then the credit hours. Let's say Bob Ross is taking 16 hours. And then to access the GPA through S GPA. Bob Ross is making a 4.0. Then when this function ends, the local variable, which is this pointer S, goes away. And we go back up to the main function where we can then print out the name, ID, credit hours, and GPA. And we can do that through the dot operator because freshman isn't a pointer. It's just a regular student variable. Okay, I want to show you this program, but first I want to show you what would happen if I accidentally tried to access one of the members using the pointer operator when my freshman is not a pointer. And then also what would happen if I tried to access the name member through the pointer S without using the pointer operator. Obviously, I'm going to have some syntax errors. You can see that with VS Code, but I just want you to see what the actual errors would look like. G++, struct pointer underscore 1.cpp. I really love the errors for this because it is so clear what the error is and what you need to do. So first it said line 34, error, base operand, a pointer operator has non-pointer type student. And it even highlights that in red saying, this is not right. So that's how you would know, okay, I don't need the pointer operator. I need the dot operator there. Okay, and then the other error is line 51, error, request for member name in S, which is a pointer type student star. Maybe you meant to use the pointer operator? I think that one's pretty funny. So yes, I definitely did mean to use the pointer operator. Now let me run this program with these errors fixed. It compiled and now I'm going to run it. So let's put in Bob Ross, 125, 16 credit hours, and 4.0. Here's the student data you entered. Bob Ross, 125, 16, 4 is the GPA. All right, Let's take a look at the two examples that has dynamic memory allocation. It should be struct DMA1, struct DMA2. I don't know why I have a DMA3, but maybe we'll take a look at that too. So DMA1, my structure is a circle. I create a pointer to a circle, C. I dynamically allocate a new circle and make C point to it. So now whenever I access this circle's members, I need to use the pointer operator, which is this arrow, to access diameter and radius and area. And then don't forget, you always want to delete anything you create with new. Since this is just a single variable I created, I don't want to use the empty square brackets. I just do delete and then the name of the pointer that points to that. Okay, let's look at the next example. Again, I have a circle structure. This time, I named my pointer circles. Then I ask the user how many circles do they have, and then I dynamically allocate an array based off of that number. So if they entered in 7, this would create 7 circle array. In other words, 7 elements. And then circles is the name of my array. Now the cool thing about arrays is you don't have to use the pointer operator, even though circles is a pointer. And I know that can be a little confusing, but because it is an array name, which is already a pointer, we can use the dot operator in conjunction with the actual index that we're accessing in the array. So whenever we read in, let's say, the radius for a particular circle, we say circles, sub, and then the index value, dot operator, radius. Same thing for diameter and area. And then I just print each of the circles out. Then, of course, don't forget to always remove anything that you create with new. Delete, since this is an array, I use the empty square brackets, then the name of the pointer that points to this array. Now I don't remember what this is, so I'm going to take a look at it. Aha! This example shows a function where you send a circle to the function, but this time we're sending a circle array. Now we could either do this in array notation like this, or in pointer notation like this. So since I already talked about structures and functions, I didn't get to talk about, well, what if you're sending a pointer to a circle, and the pointer points to an array of circles? So you can either do array notation or pointer notation, and down here it's the same thing. This is array notation, but you could also pass the array in pointer notation by putting the star in between circle and circles and removing the square brackets.